Hello everyone, welcome to the next lecture on the statistics. Today we will discuss about the median test or called as the mood median test. We will discuss the three-step rule for the non-parametric testing. Myself, Dr. Garg, working in the School of Mathematics, Thapar Institute, India. You can contact me either of my email ID. So what we have discussed so far is we have discussed various type of the non-parametric tests like run, sign, Wilcoxon, all are available at my YouTube channel. Now in this test we will see how you can define and learn about the mood median test. Mood is a statistician which has defined this median test. It is a class of the non-parametric testing. In statistics, the mood median test is a special case of the chi-square testing of the hypothesis. What this mood median test says that it is a non-parametric which are widely used to compare the medians of the two different independent samples. However, it is used also to check whether the medians of any two independent samples are equal or not. So your hypothesis will always be median 1 is median 2. You have to check whether these are correct or not. So you can say this is an alternative of the one-way Anova. All of you know that this one-way Anova is for the parametric. Whenever you have the normal distribution assumptions, then called as the parametric testing of the hypothesis. But whenever you are working on the non-parametric test, then the alternative of the one-way Anova is median test. Also, we have discussed about that the crucial Wallis test is also the alternative of this one-way Anova. But we will see the difference between them in the couple of slides. So this median test will work when one of the variable is the dependent and other is my independent variables. We all know that the sign test and the Wilcoxon test are very useful whenever there are the two different samples, sample 1 and the sample 2 have the same number of the elements, because you are using the rank. But what will happen if it consists of the n1 number of elements, if this is n2 but they are not equal, then such tests are not applicable. So under these conditions, the median test is applicable to solve to draw the influence whether they have taken from the same population or not. Or you can say the median test is a procedure for testing whether the two ordered samples differ in their center tendencies. Center tendency here particularly is my median. This is you can say the primitive two sample version of the sign test, or you can say of the one-way Anova. Once you are called about the one-way Anova, we can say it is useful for also for the two sample, but it is not powerful as of the crucial Wallis test. This is the alternative of the one-way Anova in the non-parametric testing of hypothesis. Why it is not be so useful? Because this median test uses only the median value, but not about the positions are there. This is median test is more powerful when you have the smaller sample size, but whenever the data is larger, then you have to use the crucial Wallis test. Why? Because this test used only for the median value instead of their rank are there. Usually the researcher prefers the Wilcoxon sign and the Mann-Whitney U test are there because it provides more robust results than of the median. But remember that whenever you are talking about that, you have to use the ranking are there. So median test is used to compare the k independent sample. That's why it's one alternative to the one-way Anova, but which are widely used for the medians. Before applying the median test, you have to use some assumptions. The first assumption is that whatever the observation you have taken, they are independent within and between the samples. From where the observations are taken, they are from the continuous distribution functions, provided the distribution function is either known or unknown. Since we are working on the non-parametric testing, so there is no need for the known about the distribution functions. And whatever the distribution function you have taken, the sampling have their same shape is there. You have used the mood median test in your day-to-day life. There are so many examples, like whenever you want to compare the satisfaction levels called as the dependent over the different account holders in a bank. So account holder may be the current or the savings are there. So whenever there is such kind of the problems, you are always using the median test. In other case, whenever you want to compare the machine timings of the different production lines in the manufacturing, again you have to use the median test. You can use the median test again when you are try to compare the manufacturing cycling time of the different production lines. Also, when you want to compare the monthly satisfaction level of the customer, because whenever you are talking about the satisfaction level, the people will say that it's a good, it's a very good, it's a poor, and so on. So whenever there is information like of this form, we always use the median. Or whenever you are talking about the number of the calls per week and their satisfaction level, when you are making complaint, then your observation whether the complaint is solved or not, whether your technical caution is there, whether the positive feedback is there, yes or no, and so on. So whenever there is information like this, you have to use the median test. How you can solve this median test for solving the problems are there. So we will apply the three-step approach. What is the approach is there? Consider the two different samples, x1 and x2, which consist of the n1 number of elements and n2 are there. Then we will define these three steps are there. The step number 1 is we will define the null hypothesis. We will try to compute the median and then statistics and finally draw the conclusion. What is the null hypothesis is? That is the two samples have the same population, their f1 and f2 are their distributions. How you compute the median? We all know that if you have the two different samples which consist of the n1 number of elements, n2, you have to arrange this number of samples in the ascending order. You can arrange this in the ascending orders, and you can arrange these all elements in a single row which consists of the n1 plus n2 number of elements called as the capital N. If this capital N is my odd, then you can find the median as of this, otherwise of this. Once you are finding the median, then you have to use the statistics. For this you have to complete this table. Now since there are the two samples, so that's why there are the two columns. If there are the three samples, then you have to consider the third table also. Then whatever the median you have obtained, say median is my 41, then look about the sample 1, check about these observations, check how many observations which are greater than of the medians here, write the number of the observations here. For example, if I say m1 is my number of the samples elements in the sample 1 whose values is greater than median, m2s are here. Since total is my this, so this value is nothing but my n1 minus 1 and this is n2 minus 1. Depending upon this feature of the n1 and n2, we can define this rules are. So case 1 is when these values are both or either of them is less than 10, then you can apply as a hypergeometric distribution to compute the value of p, that is n1 upon the, what is that? This is, what is this? This is nothing but my combination is there, n1 c1 r. On the other hand, whenever both of the values are greater than of the 10, then we can use the chi-square distribution as of this. All of you know that whenever you have the chi-square distribution of A, B, C, D of the 2 cross 2, then you have to add them. That's a total of this. This is my total. You can add them total for here, and this is there. And this is my grand total of A plus B. So what you can do, this is the determinant AD minus BC divided by the wholes are there. This is the NR. Make sure each of the observation A, B, C, D, each of the values are greater than of the 5. Whenever any of the observation is less than of the 5s in this A, B, C, D, then we have to apply the Zeta correction of this n by 2. Once you compute the values of this either as a chi-square or the hypergeometric, we will do the step 3rd, that is the conclusion. So whenever there are the two cases, whenever you are talking about here, that is a hypergeometric, check whether alpha is the level of significance, that is either as a 0.05. If it is less than of this, then we can reject it. On the other hand, whenever you have the more than 10, you can compute the degree of freedom. In general, it is for the R cross C. Degree of freedom corresponding to R is R minus 1, C for the C minus 1. Take the critical value. If this is greater than of this, then we can reject it, otherwise accept it. This is the table for the chi-square test. We can use them ahead. How you can read them? This is the 1. Level of significance is 5 and this value is 3.841 is more. So let's discuss these 7 to 8 examples so that you may able to understand this theory. Firstly, we will discuss about the 1 sample and then for the 2 sample. So if you read this statement, you have to investigate whether the number of the reptiles are same or not. So we will apply the 3-step rule. You have to apply the medians. Since it is given to be that whether it is given to you that the median is 10, so there is, you have to simply write H0 and H1. Your target is to complete this one. So now, since it is already a median is given to you, so there is no need to arrange them in the ascending order. If you want to write in the ascending order, you have to write like this way. Count, this is my 12, so the median will be my 12.2 plus, there is a 6th and the 7th position are there, median mean of this. How many observations which are greater than of this median 10? 1, 2, 3, 4, 5, 6. So you can see number of the observations which are greater than equal to 6 are my here. Out of total, this is my list. Now since N1 is my greater than of the 10, so we have to apply the chi-square test. How you can find the value of the E? That's a very simple. You can use the value of E as NP. N is my here, this is my total. Since there are two cases, so probability is my half, because median is probability is 50%. So the value of E is my here. This is my O1, this is my O2. So you can substitute this value as 6 minus E. E is my 6. Answer is. Now what is the degree of freedom? This is my 2 cross 1. So degree of freedom is my 1. So at the 1 of this degree of freedom, critical value is my here. Now you can see, if you draw this normal graph are there, this is my rejection region, this is my 3.84. the value of 0 lies here, that is in the accepted portion. So we can say we can accepted H0. So that is, there are not significant difference. Look at some examples related to the two samples. We will discuss here as 5 to 6 examples. Here. Now you can see the number of the elements in the N1 and N2 are not same. We can define this step 1, H0 always be here, that is the two sample have the same. What is your target is? Your target is to draw this table. This is a sample A, sample B. How many elements are there in the sample A? There are 9. Here 6. Now how you find the median? So you can write all these elements in the ascending order. Like if the smallest element is my 19, this is 19, and right here. How many elements are there? So the total observation is my 15. So what is the median? Median is my 8th position. So you can count them. This is my 8th position and this is the median. So median is my 25. Now look at that, how many observation in the A which is greater than or equal to 25. This is 1, 2, 3, 4, 5, 6. So this value is 6. How many observation which are greater than of here? This is a 1, this is 2 only. Now since you got the value of the 6 and 2, so total is my 9. You can find this value as of here. This is my 4. Now this is my step number 2. Now what is the step number 3? Since both the values are less than of the 10, so we can find this value as P, that is a hypergeometric distribution. 9C6, 6C2 divided by this sum. 9 6 are 15 and 6 2 8. After the calculation you will get here. Now what is the step number 3? Is if P is less than of the alpha, alpha is my level of significance 5%, then you can reject it, otherwise accept it. Now since this value is my greater than of the alpha, so we may accept it the H0, hence there is a no significant difference between. Look at the one more example are there. You can see there are the two different samples are there. Again this is the same as that of this. Again our target is to complete this value. How many observation in the sample 1 we call as the 18, other is 23. Arrange all the elements in the ascending order. We can write this as ascending order. What is the total number of the elements are there? You can see 18 and 23. So you can see this is my 41. So what is my median? Median is my 21st position. So which one is the 21? You can count them. This is my 21. Look at that, how many observations which are greater than or equal to 232 in this here, in the value of the A, like of 1, 2, 3, 4 and so on. So once you will count them, you will get 11 and 10. And since my here, again you can see these two values are my greater than of the 10, so we can compute as a chi-square distributions. So this is my A, this is my B, this is my C, and this is my D. So this is AD minus BC. What is the N is? The total of this is my 41, this is my 21, this is my 20. So you can substitute this value. This is my 41 is my total, this is my 21, this is my 20. So you can see AD minus BC over 21, 23, 18 and 20 are. So after the calculation you will get here. Now since it is a 2 cross 2, so what is our degree of freedom here is 2 minus 1, 2 minus 1, that is 1. And this is the value of the chi-square from the table. You can see where this value lies. 1.2 lies somewhere here. So it means it is accepted H0. So your conclusion is, since this value is less than of this, so we can accept it H0. Look at the another one is, you can see there are the 3 different samples are there, and your target is to check whether the claim is justifiable. What is the claim is, the Coop store, that is a C, have the most fish chain is here shown. Here there are the 3 stores, so we can write as the F1, F2 and F3. We can again, based on this, our target is to construct this. Now it's a 2 cross T. We can arrange them in the ascending and descending order. What is the total number of the elements are there? You can see this, how many are there, you can count them. This is my 12. So what is the median is there? That is the 6th position plus 7th position divided by 2. So you can see 20 plus 21 plus 22 upon 2. The median is my 21.5. So how many observations are there which is greater than of the 21.5? Only 1. So you can write here 1. How many observations are there? There is again only 1. How many observations which are greater than 21 is? All are there, that is a 4. So I need a total is this. So this value is my 4, this value is my 2, this value is my 0. Now since each of the observations are my less than of the 10, so we can find the hypergeometric distributions. So once you will solve this, that is a 5C1, 3C1, 4C4 divided by total. What is the total of this is 12, total of this is there. So once you will solve this, you will get this value as 0.01623. What is the step number 3 is? Since this value is my 0.01623, alpha is given, nothing is given, so it's a level of significance by 5. Since this number is less than of the alpha, so we can reject it H0. It means all these samples have not the same value. There is a significant difference between them. Look at the another values are there. So again you have to conduct the 35 students. They are asking about the restaurants chain. 11 students of the area A, 12 students from the area B and 12 students from the C. They have tell about the different conditioning, cleaning condition, taste condition and so on, and they provide their ratings are. Since there are the 3 samples, we can define the H0 are here. Again your target is to write them in the ascending order. Right here. Can you find the median is this? What is the total number of the observations? You can see 35 observations are there total. So the median will be my 18th positions is there. So what is the 18th position? You can see 18th position is my 15th. How many elements in the A which are greater than of the 15? You can see 8, 7 and 7. Now you can find complete the rest of the values are. Here you can see all these values are my greater than of the 10. So we apply the chi-square test. So how you can apply the chi-square test? You can see this formula cannot be applicable because this formula is applicable only for the 2 cross 2. But here it's a 2 cross 3. It means you have to use here. O values, these are my O. How you find the value of E? That's a very simple. You can write all these values of here. Now what is the degree of freedom for this? This is a 2 cross 3. So the degree of freedom is my 2 minus 1, 3 minus 1, that is a 2. So I can take the row sum and the column sum are. So I can find the value of that 2, that is a E of 8, that is 22 multiply 11 divided by 35. Similarly I can find the value of 7, that's 22 multiply 12 divided by here. Whatever the calculation, after the calculation you will get 6.91 here. Since this value is my 6.91, the total is 11. Can you find this value? You can easily find. This is my 7.54. Again you can easily find this because the total is 12. You can see the row is my 22, total sum is my 22. You can find the remaining one. Again this is my here, you can easily find this. So once you will compute, you can get this table. Now here you can see the value of the E, this value is less than of the 5, so you can't find this value. So what you can do is you have to pool them. What is the meaning of the pooling is you have to combine the value until all the values are greater than 5. So if you combine these two values, can their sum be greater than 5? Yes. But still this value is less than of the 5. It means you have to combine all these three values are here. Now since this value is greater than of the 5, now you can find this value. You can take this minus this here. You can take this minus this here. You can take this minus this. 13 minus 13 is 0, you can write here. Similarly, once you will write here, you can divide this value with the help of here. This is 0 by 13 is this, and so on. Now what is that? This is a summation of this. You can take the total of this. You can find the total. You will get this value. Now this is my step number 2. Now you have to take the conclusion. Degree of freedom is my 2 because we already compute the degree. This is my 2 cross 3. So what is the degree of freedom is that 2 minus 1, 3 minus 1. So that is my 1 into 2, that is my 2. But I have to subtract this one due to the pooling. Why pooling? Because you have to use this addition. So the degree of freedom is my 1. So again you can check the degree of freedom. Critical value is 3.8. Now where this value lies that? Again this value lies somewhere, that is lies in the accepted H0. So therefore your H0 may be accepted. Look at one more example are there. So now again there are the two different samples consist of the 10 men and the 20 women. So apply the median test to check whether there is any significant difference between their questionings or not. In this case it is given to you that the median is 42.5. So you have to write here. Again our target is to complete this, but remember that there is no need to arrange the data in the ascending order. Why? Because median is already given to you. You may arrange them. You can write all these values in the ascending order and then try to compute the median. Again it will be getting the same. But in this example median is already given to you, so there is no need to compute them. You just check that how many observations which are greater than of the 42.5. So you can see 1, 2, 3, 4, 5, 6, 7. So you can write in the group A there are the 7 observations. Similarly for the group B, and you can write here. Now you can see the values are my greater than or equal to 10, so we can apply the chi-square. But you can see one of the value is my less than of the 5, so we have to apply this ZA correction of the chi-square. So that is n by 2. So this is my A, this is my B, this is my C, this is my D. You can add them. This is 16, this is 14. Add them. This is my total. This is my n. So you can substitute this value here. After the calculation you will get this answer. You can see it's a 77 minus 27. What is the n is? This is my total is my 30. This is my 16 and this is my 14. So this is my n by 2. This is my here. So after that, what is the degree of freedom is? So since it is a 2 cross 2, so the degree of freedom is my 2 minus 1, 2 minus 1. That's my step number 3. Degree of freedom critical value is 3.84. Where this value lies? Again this value lies somewhere here. So it means you have to accept it H0. So that is you have to accept it H0 and conclude that they are tracking from the same populations. So this is the way you can solve this mood median test are there. If you want to find some another videos related to the non-parametric testing like run test, sign test, Wilcoxon, Mann-Whitney, KS test, crucial Wallis, as well as the chi-square test, you can simply explore this testing of the hypothesis. Channel name Dr. Harish Garg. I hope you can like, subscribe and comments on this video and share with your friends. Till then, best of luck students. Happy learning.